Alright, welcome back. We'll look at 14G, which is the a graph of sine and cos in terms of the angle. And we look at some of the transformations that we detailed before. In particular, the dilations from either axis and the reflections. Let's look at the graph of sine. So for any type of function, when you want to graph the curve, the approach will be exactly the same every time. You come up with a list of x values across your x-axis with a constant interval. You substitute those values into your function. You can use technology, you can use a regular calculator or your CAS calculator. You evaluate the respective y value, and for each column you will round it off. You do an estimation to a decimal place, and you place those. Every column will represent a point, and every point you will place on your Cartesian plane, and then with a pen or pencil, you will join the points from the left to the right to look at what the curve looks like. Here, instead, we're going to use knowledge that we had from the previous exercise, which is the exact values. In the first quadrant, so the first quadrant is from 0 to pi on 2. We're gonna just break it down just to 0, pi on 4, and pi on 2. So remember, in degrees, it's 0 degrees, 45 degrees, and 90 degrees. We'll get those values. So it goes from 0 to 1 over root 2 and up to 1. So it's increasing. So the curve is going up, and then it starts going back down to -1, and it keeps going back up. Okay. Yeah, so that's what it would look like. Let me remove that for a second. Alright, so now we have our sine function here. First quadrant, that's the blue rectangle. It's from 0 and it goes all the way to 1 for a value of pi on 2. So here on the x-axis, so y equals sine of x, that x is actually the angle in radian. So for the first quadrant, it's from 0 to pi on 2. Pi on 2 to pi is your second quadrant. 3 pi on 2 is your third quadrant. And up to 2 pi, it's your fourth quadrant. And then it starts again. And I'll talk about it, the fact that the function, so that first wave from 0 all the way to 2 pi, notice how we go back to the same starting point, and then it starts repeating again. I'll talk about this is the fact that it is a periodic function. Alright, how do we link that to, it's a little bit of an animation, you can find it on the internet. So as your point is going around your unit circle, we're focusing on cos and sine of theta that represents the x and y coordinate of that point. So as your point is moving around, let's look at the blue curve. Your x coordinate is going from -1 and it goes up and it oscillates. It keeps changing, repeating. Alright, looking at the sine of x, that sine of x again is the y coordinate of that point going around the unit circle. The graph repeats itself after an interval of 2 pi units on the x-axis. A function that repeats itself regularly is called a periodic function, and the interval between the repetitions is called the period of the function, also called the wavelength. If you do physics, it's also called, it's the term that is going to be used. So sine of x has a period of 2 pi units. Okay. Um, and then what we're going to talk is about the highest value. So the highest value is going to be, the maximum is 1 and the minimum is -1. The distance, and we're going to talk about the vertical distance, the distance between the mean position is when it's 0, and the maximum is called the amplitude, and the amplitude is 1. All right, let's go back to the period. So the period is, if you take any point on the curve, so let's say I can do that with 0, but let's say I take the maximum. You can see there's another maximum there. Well, that distance between the two is 2 pi. And that is the length, the wavelength, or the period. It's the same from 0 to 2 pi. Now the mean value is when y equals 0, so that's your mean value, that's your x-axis. And to go all the way to 1, that's your amplitude. Alright, now let's look at cos as a function. So in red we have sine. Sine of 0 is 0, so sine is easily recognizable as it goes through the origin. So it goes through 0, it goes up to 1, at pi it goes back to 0, it goes down and up to back to 0 at 2 pi. That's your sine function. Your cos function has the same curve as a sine, but it's actually a translation. Okay, and it's a translation to the left of pi on 2. So you see that peak is at pi on 2. You get a certain peak at 0 because cos of 0 is equal to 1. Cos of pi on 2 is 0. Cos of pi is -1. And then when you get to 2 pi, cos of 2 pi again is 1. Alright, so it will have similar properties as sine. Same with the period, the same with the amplitude. Alright, now let's look at some variations of sine and cos. Let's look at two dilations. The dilation of coefficient a and n. N is going to be, we're going to make it easier, it's positive. And a as well. A is a coefficient in front of your function sine and cos, and n is going to be a coefficient in front of x inside the brackets. Now as you a in front, remember for a regular function a is equal to 1, so sine of x and cos of x will have a value of 1. The amplitude was 1, so here in that situation the amplitude is based on the a value. So the amplitude is a, and that would determine the range because the amplitude is from the mean value. So the range will be -a to +a, and it's the same for cos. I summarize all that in a table because they're very similar. Okay. Now the dilation that it is, it's a factor a, and it's from the x-axis. So as a increases, let's say a equals 2, you would double the function compared to y equals sine of x or y equals of cos of x respectively. For the period, it has to be, the period will be affected by that n coefficient in front of x. Now the difference here is the period will be divided by n. So as n increases, the period is smaller, the wavelength is smaller. Just be careful with the dilation. It's a dilation from the y-axis, from the graph of y equals sine of x or cos of x, but the dilation factor is 1 over n. So here if n equals 2, The factor is 1 over 2. Very important that you know the difference between the two dilations and how to implement it the way you would write your statement as a transformation. To summarize that, when you have a point xy from either y equals sine of x or y equals cos of x, when you have your dilation factors a and n, the mapping is to x over n and respectively a y. Okay, that's going back to when we use matrices and we use the mapping of coordinates or mapping relations. That's how it's linked back to that. All right, first example. Simple enough. I would pause that video. Here you don't have to graph it yet. All you need to do is state the amplitude and period. So if you pause that, you can jot down right on paper, or you can probably remember and think, well, looking at this, how do we determine the amplitude and the period? You will need the information from the previous slide. Okay, let's move on. So the coefficient in front of your function for here is 2, here is negative 1 over 2, so you ignore the negative for the amplitude, and here is 4. So the amplitude is determined by that coefficient. You ignore the negative. The amplitude is always positive. Now you look at the coefficient next to the t variable or the x variable, depending on how you they kind of interchangeable. We can use, if your Cartesian plane is labeled xy, you would use x and y notation. Here it's in terms of t for time, or it could be a Greek letter like theta if you wanted to talk about an angle. So here in front of the t you have a 3. You take that n value and you apply the formula 2 pi over 3, and that will give you your period. You leave it as in simplified fraction. Here 2 pi divided by 1 over 2, you need to simplify that. That gives you 4 pi, and here 2 pi over 3 pi, that gives you 2/3. Now if you have 2 pi over 3, remember pi is a constant, and we can approximate 2 pi to 3.14, and you can evaluate that. It's going to be close to 2 something. Alright, another one. This time you need to state, you have a sequence of transformations, again from y equals sine of x. So you need to list them and state the amplitude and the period. So with the first one, what we can see is you have a 3 and 2. So the 3 says you have a dilation of factor 3 from the x-axis, and the next one is going to be a dilation from the y-axis of factor. You do the reciprocal, so it's going to be 1 over 2. Okay, the amplitude is 3, and the period is going to be 2 pi divided by 2, which is pi. Have a go at the next one. Alright, with the next one, dilation of factor 4 from the x-axis. The 1 over 2, again you take the reciprocal. That's a trick here. So it's 1 over 2 times x. The reciprocal of 1 over 2 is 2. So the second dilation from the y-axis is over factor 2. That's where it's coming from. We're doing 1 divided by 1 over 2. That's how you get the 2. The amplitude is 4. You do 2 pi divided by 1 over 2, so that's times 2, that's 4 pi, and that will be your new period. Okay, now to make things a little bit more advanced, you start again by determining your amplitude, your period. You can link back to what kind of dilations you get, and then you should be able to sketch the graphs. Okay, now do remember important values to use is your starting point. So cos for theta or x equals 0, cos of 0 is 1 and sine of 0 is 0. So that helps you with your starting point. One complete cycle is a full period. So for each one of them, so let's start with the first one. The 2 in front is the amplitude. The 2 next to theta, we're going to divide by that amount from 2 pi. So the period is pi. As we have the amplitude tells me the starting point is going to be at 1 times 2. The period is pi, meaning later that is pi. And I'm going to have a repeat of the starting point because that distance is the period. Then what I like to do usually is in the middle. So if I divide by 2, that's the maximum. If I go to the middle to power 2, I get the minimum. And from 0 to power 2, if I divide by 2, I get 0 because I go from the maximum down to the minimum. And in the second half, from pi over 2 to pi, because I go from -2 to 2, I cross over the x-axis or the theta axis at 0 again. And then you can join it together. Okay? Alright, with the next one, the period. Let's start with the amplitude. The amplitude is 1 over 2. So that's what you get. So because it's 1 over 2, just hold on. Alright, because the amplitude is 1 over 2, so again, sine of 0 is 0. So that's your starting point. You have a 1 over 2 here, so the period is 4 pi. So when you have sine of 0 is 0, if you add 4 pi, you get 0 again. In the middle, at 2 pi, it's going to be the middle because that's 2 pi is half of 4 pi, so it's going to be 0 again. And as you divide it by 2, that gives you pi in the middle. That's where you get your maximum, and that is coming from your amplitude. For between 2 pi and 4 pi at 3 pi, we get the minimum. So it's the opposite of your amplitude. And then you can join it together. Okay? So whatever works for you to be able to sort of graph that in your book yourself. Just a reminder as well, when you have the graph, if you start with y equals sine of x, you can get that transform function by a dilation of factor 1 over 2 from the x-axis. It means you stretch it out to a period of 4 pi. And then the dilation of factor 2, it's a typo. It's a factor 1 over 2 here. That should be 1 over 2 from the y-axis. You can see the amplitude gets shrinked by a factor 1 over 2, so that becomes 1 over 2 and -1 over 2. Okay, so be mindful, this is a typo here. Wait, my bad. It's correct. I've done that backwards. The factor 1 over 2 from the x-axis is correct. That's the 1. When you have the 1 over 2 here, we get a period of 4 pi. That's when we get a factor 2 from the y-axis, so it gets stretched out from 2 pi to 4 pi. So I did that backwards, my bad. Alright. Again, I know it's a little bit repetitive, but it's really to reinforce the concept. So first, you need to find your amplitude and your period. Now here it specified to you the interval. That might not be a full period, or it can be more than one period. Alright, the amplitude is 3, the period is 2 pi divided by pi, which is the coefficient, so that gives you a period of 2. That 2 is matching your length that you for the domain, meaning you need to graph one period only. Again, you start at 0, you end at 0, the middle value is going to be 0 again, and then you can just go to the halfway to the maximum, which is 3, go down to 0 again halfway through, and go to the lower value or minimum of -3 and go back to 0. Okay. Now, if you the 3 here tells us it's a dilation of factor 3 from the t-axis, so the horizontal line, so that's why you have an amplitude of 3, and it's a dilation of factor 1 over pi from the y-axis, so instead of having a period of 2 pi, it gets shrinked to a period of 2, and that's from the y-axis. Okay, reflections. So the transformation is a reflection in the vertical axis or the y-axis. Do remember, sine of negative x is negative sine of x, and cos of negative x is cos of x. So let's look at y equals cos of x. If you reflect it in the y-axis, it gets transformed exactly the same. So what you would do is, let's say you have a point alpha beta that belongs to this one. If you substitute alpha with negative alpha into the function, cos of negative alpha is cos of alpha, that will give you the same coordinate. So the beta will be exactly the same. So with cos looks like this on the right hand side. If I do a reflection, you get exactly the same. Okay, now with y equals sine of x, if you do a reflection, it gets transformed into the negative. So let me show you. So with sine starts at 0, it goes up and down like that. Okay, now if you do a reflection, you don't get a mirror image like cos, it actually goes down, and that bit in dot is also negative sine of x. It's a reflection from the x-axis. Okay, so when you try to do a reflection from the y-axis, you get negative sine of x, and the fact that is a negative sine of x, that negative tells me it's also a reflection of sine from the x-axis. Confused? All right, so that's the reflection in the vertical axis, and that negative sine is just negative sine of x. All right, last example. You have an interval, a domain from 0 to 4 pi. You have two functions that you need to sketch on your Cartesian plane. Just do remember what you need to do again is going to be the same process, two steps, the amplitude and the period. Okay, so for the first one, the period is 2, here the period is 1. Okay, the negative, you're going to deal with the reflection. Okay, the period, so it's 2 pi divided by 1 over 2, so that gives you 4 pi for part A. For part B is 2 pi divided by 2, which is pi, so it's going to be closer, a smaller period. Here it's a longer double period, and here it's a half period of 2 pi. Okay, so the amplitude is 2, the period is 4 pi, so you can do that. And what we do is you graph your sine, and because there's a negative, you need to do a reflection in the x-axis. So it used to be sine, it will go up and go through 0 and down. You just flip it across the x-axis like a mirror image. Okay, cos of 2x, amplitude is 1, period is pi. Okay, now because it's pi and we need to go from 0 to 4 pi, you're going to need to draw 4 periods. Because it's a negative, you're going to start at -1. So you start at -1 and you need to do 4 periods. So if I go across, plus pi, that's 1, 2, 3, 4. Okay, and that's your 4 periods. Because it's a reflection in the x-axis of cos, you start at -1, you go all the way up to 1 and all the way back down to -1 for a full period, and you repeat. Okay, so it's a translation. You translate by pi 3 more times. And that's it. And I'll see you next time.